Let's start the class. Okay, today we will have heavy material, 5.2, heavy, but each one of them actually quite small. 5.2 it's the very basic one. Okay, we will start with the very basic narrow definition of trig functions, and we will start from an acute angle in a right triangle. So suppose I have a right triangle. And let's say this is right triangle here, and this is angle theta. Okay, let's call this the opposite of angle theta. That's why you call it the opposite. And then this side here is the adjacent. And this is the hypotenuse. Now, the definition is as the following. Sine of theta denoted by sine theta is defined as the opposite over the hypotenuse. Cosine of theta is defined to be cosine of theta that's adjacent over the hypotenuse. Now, tangent of theta denoted by tan theta is defined as the opposite of that angle theta over the adjacent. Now, these three trig functions here, sine, cosine, tangent, are defined as the primary trig function. If there are only three trig functions you need to memorize, it will be these three. Okay, now I somehow remember one of the prerequisites for this class is geometry, and in geometry you already learned this definition. Okay, but let's go on. Secant of theta denoted by sec theta, that's defined to be the reciprocal of cosine theta. So the reciprocal of cosine theta is hypotenuse over adjacent. Cosecant theta cosecant of theta denoted by CSC theta is the reciprocal of sine theta. Therefore, the formula will be hypotenuse over opposite. Now, cotangent theta denoted by COT theta is the reciprocal of tangent theta. So that will be adjacent over opposite. Now you need to memorize this definition. Okay. Now the last three trig functions here are called secondary trig functions. Okay, they are important, but not as important as the primary one. Now, based on this definition, then we can do problems right away from our textbook. For example, if we take a look on let's do number 4 first. Number 4. Number 4, we have a right triangle, looks like the one we have up there. And we have angle theta here, right angle here. The opposite is 8, adjacent is 15, and hypotenuse is 17. So what is sine theta? How about cosine theta? How about tangent theta? How about secant theta? Cosecant theta and cotangent theta. Now, sine theta is the opposite of theta, which is 8 over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is opposite over adjacent. Am I okay? I somehow feel I'm a bit too fast. Now, secant is the reciprocal of cosine. That is 17 over 15. While cosecant is the reciprocal of sine. That is 17 over 8. Now, cotangent is the reciprocal of tangent. That's 15 over 8. Now, I hope you find that to be easy enough. Okay, now let's take a look on number 6. Suppose I have this right triangle, very similar, but this time the angle is located on the top right instead. So this is the theta instead. This is right angle. This is 1. This is 3. Now then we need to find the length of this side first. This is the opposite, right? Let me call that B for now. So by Pythagorean theorem, 1 squared plus B squared equals to C squared. So B squared equals to 9 minus 1, which is 8. So B is, should be plus minus, but B is the length here. So I will just use the positive branch, square root of 8, which is 2 radical 2. Now then, what is sine theta? Opposite of theta is 2 radical 2 over hypotenuse. Cosine theta is the adjacent over the hypotenuse. Tangent theta is the opposite over adjacent, which is just 2 radical 2. Now, secant theta is the reciprocal of cosine. That's 3 over 1, which is 3. Cosecant theta is reciprocal of sine theta. That's 3 over 2 radical 2. Rationalize the denominator. I get 3 radical 2 over 2 times 2, which is 4. Tangent theta, cotangent theta is the reciprocal of tangent. Multiply by radical 2 on the top and the bottom gives me radical 2 over 4. Okay, now number 8 is even more abstract. Instead of giving us numbers, we will get variables. So for number 8, we have a right triangle again. The hypotenuse and the angle is on the top right. That's the theta here. The hypotenuse is C. The adjacent of that theta is A. Now suppose we call this B, A squared plus B squared equals to C squared. I need to express that B in terms of C and A. So B squared is C squared minus A squared. So the B is square root of C squared minus A squared. Now then, let me ask you to do this. What is sine theta, cosine theta, tangent theta, secant theta, cosecant theta, and cotangent theta? Okay, please do that. Let me give you 1 minute for this. Okay, sine theta, the opposite of theta is square root of C squared minus A squared over hypotenuse C. Cosine theta is the adjacent over the hypotenuse. Tangent theta is the opposite of theta over adjacent. Secant theta is the reciprocal of cosine. Cosecant theta is the reciprocal of sine. And cotangent theta is the reciprocal of tangent. Okay, in fact, you basically see this formula basically in the general form. Now, suppose we are given the following situation. So for example, the second group of example, suppose we have number 18. They say that theta is an acute angle that is in quadrant 1. Okay, that's actually a short way to say theta is acute angle. It is in quadrant 1. And cosine theta is 8 over 17. Now then, find the value, the exact values of the other trig functions. Of theta. Okay, now how do we do that? First, you draw a right triangle. You draw a right triangle that is corresponding to the given informations. So suppose this is my theta. Okay, now cosine theta is 8 over 17. So you can say the 8 is the adjacent, 17 is the hypotenuse. Now that is cosine theta, right? Now then you use Pythagorean theorem, which if you happen to memorize Pythagorean triplets, then you know this is 15. Now let me go back to what I call Pythagorean triplets first. I will box it here. Memorize. These Pythagorean triplets. Pythagorean triples are three numbers, three integers that satisfy Pythagorean theorem. Now, the one that you already know is 3, 4, 5, right? Of course, the longest one must be the hypotenuse, right? If we say 3, 4, 5 is a triple, it means 3 squared plus 4 squared equals to 5 squares. That's what it means. Okay, now, but other Pythagorean triplets you should memorize are 7, 12, 13, 8, 15, 17, and then 7, 8, 5, I'm sorry, 5, 12, 13. 5, 12, 13, and then 7, 24, 25. Okay, there are a lot of Pythagorean triplets. Actually, there are infinitely many Pythagorean triplets. But the ones show up a lot in trigonometry are these four. Now, the good thing is if you have a Pythagorean triples, then every multiple of that also a triple. Suppose, for example, I multiply this by 2. Then the triples will be 6, 8, 10, right? Okay, now every multiple of Pythagorean triples must be a triples itself. Okay, so basically I'm saying that 6 squared plus 8 squared is equal to 10 squared. Okay. Now let's say instead of multiplying, let me divide instead by 10. Okay, so 0.5, 1.2, and 1.3, also a triples. Okay. 21, 72, 75, also a triple. Okay, now with this knowledge of basic Pythagorean triples, it helps you speeding up your computation a lot in trigonometry. Now, with this said, then once we get this, so if you don't memorize the triples, then just use Pythagorean theorem. Okay, you need to get that 15 first. Okay, now then from there you see, oh, sine theta equals to 15 over 17. We already have cosine theta, that's given. Tangent theta is 15 over 8. Okay, secant theta, that's the reciprocal of cosine. Cosecant theta, that's the reciprocal of sine. And cotangent theta is the reciprocal of tangent. Boom, you're done. Okay, and that applies to other type of questions though. It doesn't have to be cosine. Let's say number 22. Let's say number 22, cosec theta is in quadrant 1, and cosecant theta is 4 over 3. Now, as long as it is a right triangle, as long as the angle is an acute angle, then you can always draw this right triangle corresponding to that situation. Okay, cosecant theta is 4 over 3. It means the sine theta is 3 over 4. Right? If this is 3, this is 4, then this will be square root of 16 minus 9, which is square root of 7. Now then from there you go on, oh, sine theta is the reciprocal of cosecant, that's 3, 4. How about cosine theta? That's radical 7 over 4. How about tangent theta? That's 3 over radical 7. Rationalize the denominator. That's 3 radical 7 over 7. Okay. Now the secant and cotangent, you do reciprocal here and there. Okay. Now that's the first part. The emphasis, no, I should not say the emphasis. We have some trig functions for special angles. I call that A star. Trig values for special acute angles. And those special acute angles are 30 degrees, 45 degrees, and 60 degrees. Now we will develop and later on memorize the value of sine, cosine, tangent of these three special angles. I will start from 45-degree triangles. The way we achieve 45-degree triangle is by getting a square that we bisect diagonally. Okay, suppose the side of that square is A, then the hypotenuse must be A square root of 2. Now, because this angle here is the bisection of a right angle, then automatically this will be 45 degrees triangle. That's 45 degrees, and this must be 45 degrees also. Okay, in geometry, you have learned that if you have isosceles right triangle, that refers to 45-degree triangle. Okay, that refers to 45 degrees triangle. If you have isosceles right triangle, then it must imply this R 45 degrees triangle. Now, what I need you to have is now the ratio. Memorize this triangle, memorize the picture. Okay, if this is A, this is A, this is A radical 2. Or if you say that A is equal to 1, then this will be radical 2. Okay, in other words, from the leg to hypotenuse, you multiply by radical 2. From the leg to hypotenuse, you multiply by radical 2. From hypotenuse back to the leg, of course, you divide by radical 2. Okay, and the ratio of two legs, they are equal to each other. Now, at least from here, using these triangles, then we can see that sine 45 degrees is 1 over radical 2, which is radical 2 over 2 if we rationalize that. Cosine 45 degrees is the same. Tangent 45 degrees is 1 over 1, which is just 1. Okay, I need you to memorize this. The earlier you memorize this, the better you are in trigonometry. Next, for 60 degree, 30 degrees and 60 degrees triangle, they actually come from an equilateral triangle. So imagine we have an equilateral triangle. Okay, of course, because it is an equilateral triangle, because all three sides are congruent, then the opposite sides are also congruent. That forces the interior angles to be 60 degrees. Okay, now then, what we will do the angle bisection from the top vertex. And from geometry, we learn if you do angle bisection in an equilateral triangle, that angle bisection will also be the perpendicular bisection. And therefore, the angles here becomes 30 degrees, 30 degrees. And this segment here, this segment here must be the altitude. Okay. Now, how about the ratio? Suppose the length here is 2a. Because three sides are congruent, then this must be 2a, this must be 2a also, right? Now, if I pick one of the right triangle here out, if I pick one of the right triangle out, I'm sorry. Then this angle here will be 60 degrees, this is 90 degrees, this is 30 degrees, this is 2a, and this must be a. By Pythagorean theorem, then the other leg must be a radical 3. Yeah, just apply the Pythagorean theorem. Now, if I change the a to be 1, then the other leg is radical 3, and the hypotenuse becomes 2. Okay, now in a 30-60 degree right triangle, the shortest side must be the opposite of 30. Okay, the ratio from the shortest to the longest is 1 to 2 ratio. The ratio is 1 to 2. Okay, while the ratio from the shortest to the other side, the other leg, is radical 3. Why do I need to teach it that way? First, then from there, let's get the trig values first. Okay, so sine 30 degrees is opposite 1 over hypotenuse 2. Cosine 30 degrees is the adjacent radical 3 over hypotenuse 2. Tangent 30 degrees is opposite over adjacent, which is radical 3 over 3. Now that's the trig values of 30 degrees. What am I doing? Memorize this. Now, likewise, using the same triangle, we can get sine 60 degrees, which is opposite of 60 degrees is radical 3 over hypotenuse 2. Cosine 60 degrees is the adjacent 1 over hypotenuse 2. And tangent 60 degrees is opposite radical 3 over adjacent 1, which is just radical 3. Okay, you need to memorize this. Those things that I asked you to memorize, the one I box, I strongly suggest you to, when you study, copy that on your cheat sheet. Okay, create some kind of flashcards. Okay, it doesn't have to be at the size of flashcard. You can make it even bigger. But in that flashcard, you have these boxes to help you memorize. Okay, when it comes to trigonometry part, we will have a lot of memorization, a lot of memorization. Okay. Now, let's take a look on, for example, number 12. Number 12, we have this right triangle where the angle on the bottom left is 60 degrees. Now they tell us this is 3, this is x, and this is y. How do we do this kind of question? Remember the ratio, 60 degrees, okay, means the opposite is for radical 3, the adjacent is for 1, and the hypotenuse is for 2. Those are the ratio. Okay. In other words, from this side here to go to that side, you multiply by radical 3. Okay. And from this side to that side, you multiply by 2. So let me get the y first. Okay. Radical 3 times y equals 3. So y will be 3 over radical 3 multiplied by radical 3 on the top and the bottom. That gives me 3 radical 3 over 3. That's radical 3. Okay, and x is equals to 2y. So x will be 2 radical 3. That's it. Number 14. We have now a right triangle with the angle on the bottom left is 30 degrees. So the ratio is 1 radical 3, 2. That's the ratio. Now, but in the question, they say that the hypotenuse is 10. What is this x here? And what is this y here? If the shortest side is x, then the longest is 10. Okay, 2x equals to 10. So from there, we get x equals to 5. Can you follow me? Or maybe you prefer me to write it this way. Let's write it this way. Let's write it this way. Now, 1 over 2, this guy over this guy, is equal to x over 10. What do you think about this? Do you feel better with this? Now, then from there, you see 10 equals to 2x, so x equals to 5. Right? Okay, so you see that from similar triangle point of view. Okay, I myself prefer to say it this way though. The way I want to train you is this. Always, if you have 30, 60 degree triangles, then use the opposite of 30 degrees as your base. From here to here, you multiply by 2. So if you go backward, you divide by 2. From here to here, you multiply by radical 3. So the y will be x times radical 3. Now, doing the ratio will slow you down, even though that's right. Okay, doing the ratio is one way to do it. Okay, but if you want to go faster for these special triangles, memorize the ratio. Okay, opposite of 30 degrees is the shortest one. This is the shortest one. From here to here, multiply by 2. From here to here, multiply by radical 3. Okay, this is 60 degrees, so this is the shortest one, right? From here to here, multiply by radical 3. So if you know this is 3, you want to go backward, you divide by radical 3. Now, once you get this going there, you multiply by 2. That's how I usually train my SAT student. Okay, that is actually a lot faster. That is actually a lot faster. Okay. Now, what happens if you have number 16, which is 45 degrees triangle? So this is 45 degrees here, and this is 4. What is x? What is y? Because this is 45 degrees triangle, x must be equals to y, right? X equals to y. That one we know. Now, the ratio is 1, 1, radical 2. That's the ratio. In other words, from x to the hypotenuse, you multiply by radical 2. Okay? X times radical 2 equals to 4. So x will be 4 over radical 2. Get the boom, that's 2 radical 2. Likewise, y is 2 radical 2. Now, you want to see the slowest method? Okay, the slowest but still right method. But if you do it this way, and if you do it this way and this is the only thing you can do, then good luck with this class. I cannot stand it. It's way too slow. What is that? People may do it this way. Oh, you know what? X over 4 is the sine of 45 degrees. And sine of 45 degrees is 1 over radical 2. And then cross multiply. So 4 equals to radical 2x. So x is 4 over radical 2. This is 2 radical 2. Now, if you do it this way, you still get the same answer with me. Okay, x is 2 radical 2. But you have to relate that to sine, cosine, tangent 45 degrees. You know, and I believe this is the purpose of what our textbook wants you to do. Okay, what I want you to do instead is visually memorize the ratio. Oops, I'm sorry. Visually memorize the ratio. When you have 45 degrees triangle, from the leg to hypotenuse multiplied by radical 2. Multiply by radical 2. So if you go backward, you divide by radical 2. Okay. Now, how about 30-60 degree triangles? Now, opposite of 30 degrees is the shortest. From here to the other leg, multiply by radical 3. From here to the hypotenuse, multiply by 2. So once you know how to go from the shortest one to multiply by radical 3 for the other leg, multiply by 2 for the hypotenuse, then we can go backward later on. Okay, we go backward later on. Now, anyway, let me summarize our trig values of special angles for now. For angle theta, 30 degrees, 45 degrees, 60 degrees, sine theta, cosine theta, tangent theta. By Thursday, you have to memorize this already. Sine 30 degrees is 1/2. Cosine of 30 degrees radical 3 over 2. Tangent 30 degrees is 1 over radical 3, which is radical 3 over 3. Sine 45 degrees is 1 over radical 2, which is radical 2 over 2. Likewise for cosine. The tangent is 1. Sine 60 degrees radical 3 over 2, cosine 60 degrees 1/2, tangent 60 degrees radical 3. Okay, so this box here basically summarizes those three boxes together. 1, 2, 3 boxes here. I put these three boxes in this one big box. And this box will get larger. This box will get larger. Now we are done with part A in 40 minutes. Oh, wow. That's trig functions of an acute angle and trig functions of special angles that are acute angles. Now, part B. How about trig functions of any angles? Of any angles. What we will do is we will enlarge the definition of trig functions of an acute angle into larger angles, and it is by doing the following. I will superimpose that right triangle into a unit circle. No, doesn't have to be unit circle, I'm sorry. Into a circle with radius r. Okay, and the definition will be as the following. Suppose angle theta is in standard position. It means from positive x-axis going counterclockwise. And the coordinate on that circle is coordinate x, y. And of course, this is r, right? Now then, sine theta is defined to be y over r. Now, even though this seems like a new way to define sine, but it is actually still consistent to the acute triangle view. Okay, because if that coordinate is x, y, then this guy here is x. And this guy here is y. Now, sine theta in that right triangle is the opposite of the angle theta, which is y, over hypotenuse, which is r. Okay, that's what I meant by we are enlarging the definition of trig functions instead of only apply to acute angle, which still worked, right? But later on, our theta may be more than 90 degrees. Okay, now sine theta is defined to be y over r. Cosine theta is defined to be x over r. Tangent theta is defined to be y over x. Okay, now suppose, for example, I pick questions number 76. You have coordinate p, -8, -15. -8, -15. So let's say it's approximately here. -8, -15. So the angle for that will be this angle here. Okay, this is the angle. That's the angle. Now, can you tell what's the radius by just looking at that? That's one of the triplet, right? 8, 15, 17. Okay, now then, sine of that angle, let me use angle theta. I have another theta there. Let me use alpha. Let me use angle alpha, okay? Now, sine alpha, using our definition, that will be y over r, -15 That's the y over r, always positive 17 in this case. Cosine alpha will be dx, that's negative 8, over the radius 17. Okay, and tangent alpha is the y over x, negative 15 over negative 8, which is 15 over 8. Okay, now do not underestimate this this approach here. Do not underestimate this approach here. Okay, now before I go on with the later question, let me first say that in quadrant one, x and y are positive, right? The r is always positive. So what happened is in quadrant one, positive over positive for sine, that's positive. The cosine is positive over positive, also positive. Now because x and y are positive, then tangent also positive. Now you will see that in quadrant one, all positive. All sine, cosine, tangent are all positive. Now in quadrant two, however, the x is negative. The y is positive, the x is negative. Okay, only the y is positive. Only the y is positive, the x is negative. Okay, so you see in quadrant two, what happened is only sine positive. Only sine positive. Consequently, cosecant also positive. Okay, of those 6 trig functions, if sine is positive, then the reciprocal cosecant also positive. Now in quadrant 3, the x and the y are negatives, right? So y will be negative, x will be negative. Okay, so you see sine and cosine will be negative in quadrant 3. Only tangent is positive because that's the quotient of 2 negatives. So in quadrant 3, only tangent is positive. Only tangent is positive. And in quadrant 4, likewise, only cosine is positive. Of those 3 functions, only cosine is positive. So the way you memorize is this. Quadrant 1, all positive. Quadrant 2, the sine is positive because y is positive. Quadrant 3, the tangent is positive because both x and y are negative. They, negative over negative becomes positive for tangent. All sine, tan, cos. Okay, now how do we use that though? How do we use that? Let's take a look, for example, on number 88 first. Number 88. The question is, which quadrant is theta located? Part A. If tangent is negative, yet cosine is positive, tangent negative, cosine positive. Now cosine positive Only cosine positive in quadrant 4. So theta is in quadrant 4. Part B. Secant positive, tangent is negative. Secant theta is positive, tangent theta is negative. But if secant theta is positive, that implies the cosine also positive, right? The reciprocal. Now, cosine positive, tangent negative, that implies theta is in quadrant 4 also. Part C. Cosecant theta is positive. Cotangent theta is negative. Cosecant theta is positive means the sign is positive. Cotangent theta is negative means tangent theta is negative. Now, which quadrant? That only sign positive. Then theta must be in quadrant 2. Okay, then finally, part D, cosine theta is negative and cosecant theta is negative. Now, cosecant theta is negative means sine theta is negative. Now, which quadrant is cosine and sine are negative? Both sine and cosine negative. That's only quadrant 3. Right? Okay, that's quadrant 3. Now, how do we use this? How do we use this fact? Number 90. Suppose they tell us that cotangent theta is 3/4 and cosine theta is negative. Now, cotangent theta is 3/4 means tangent theta is 4/3, which is positive. Right? Tangent is positive, cosine is negative means theta is in which quadrant? Tangent is positive, cosine negative, theta is in quadrant 3. Now, picture that on the coordinate system. The y is 4, the x is 3, but it has to be negative 3 in quadrant 3. So let's use the y is negative 4 and the x is negative 3. Okay, so this is negative 3, negative 4, right? Now, this angle theta here must satisfy that given condition, that is, the cotangent theta is 3/4 and cosine theta is negative. Now, once you get this, then you can find the hypotenuse, which is, can you do it fast? What's the hypotenuse? 345, right? Okay, now then, from there, you can work on the other trig functions. For example, what is sine theta? Sine theta will be y over r. Cosine theta will be x over r. Tangent theta, that's the reciprocal of cotangent. We already get that. And secant theta, that's the reciprocal of cosine. Okay. And then cosecant theta is the reciprocal of sine. Okay. Now, my point is this. From what you know here, you get the quadrant, and then sketch that correctly. Sketch that correctly. Okay, once you sketch that correctly, then you can just use the definition later on for sine, cosine thingy. Okay, now let's do the harder one, number 94. Number 94. Cosecant theta equals to 5, while cotangent theta is negative. Now that means sine theta equals to 1/5, right? Which is positive. Now, tangent theta is negative. Which quadrant will that be if the sine is positive but the tangent is negative? The y is positive, but the ratio of x and y is negative. Yeah, because tangent theta is y over x, right? So if tangent theta is negative, means they have opposite sign. If they have opposite sign, it must be either quadrant 2 or quadrant 4. But the sign, which tell us the y over r, y in this case is positive. R is always positive. So which quadrant is it such that x and y have opposite signs, but the y is positive? Oh, that must be in quadrant 2. Okay. The y is positive, must be 1 or 2. Right? But the x and y must be opposite sign, and must be this one. Okay, now then picture that on your coordinate system. Make the y equals to 1, but the r equals to 5. 1, but the radius is 5. If this is 1, the radius is 5. Then what will be the other side? That will be square root of 25 minus 1, which is square root of 24, which is 2 radical 6. Right? So the x will be negative 2 radical 6, comma 1. You can just leave it for radical 24 for now, but if I were you, I will simplify that right away. Now, once you get the coordinate, then you can work on that. Well, sine theta, we already know that's y over r. Cosine theta is the x over r. Tangent theta is y over r. That's radical 6, negative radical 6 over 12. And then secant theta, that's just the reciprocal, negative 5 over 2 radical 6. That's negative 5 radical 6 over 12. Cosecant theta, reciprocal of sine, that's 5 over 1. And cotangent theta is negative 2 radical 6 over 1. Okay, the big challenge. Big challenge. I wonder if I pronounce it correctly. I don't know. Let me use big question instead. Let theta be in quadrant 4 and sine theta is x. Let's say find cosine theta. Find cosine theta. Solution in terms of x, of course. Now, draw the triangle, draw the position first. Okay. And you can see this sine x as x over 1. Okay. In other words, you can set up the radius to be 1 and the y component is x. This is 1. The y component is x. Ooh, that's confusing, huh? Then what will the x component be in terms of x? If this is x, what will this be? Now, instead of using x, let's use something else. Instead of using x, let's use a instead. So this is a. Then what will x be? X will be square root of 1 squared minus a squared, right? Isn't it y part is z, y part is x? Yeah, that's why I replaced that so that the y part is x, but I don't want you to confuse that x with the x component. That's why I changed it to a. I changed the x becomes a. Is it okay? Yeah, so x equals to a. Now, my question here, is a positive or negative? Is a positive or negative? Yeah, a is negative because it's in quadrant 4. Okay. Now, but then from here you see cosine theta is equals to the x component over radius 1, or simply square root of 1 minus a squared. Okay. Now, how about tangent theta? Suppose I go on find out what is tangent theta. Tangent theta will be the y over x, right? Now, is this tangent theta positive or negative? Good question. That's negative. That's right. Why? Because a is negative. That's negative. Okay. Now, square root of anything will be positive, right? Negative over positive, that will be negative. In other words, it seems like tangent theta has no negative sign. And you may wonder, oh, how can it be theta is in quadrant 4, but tangent is positive? How do you know tangent is positive? Because no negative sign there. No, that's not right. Okay, the negative sign is the negative already inside that a. A itself already negative. Okay, a itself is already negative. Now, last part before I give you a break is quadrantal angles. What happens if the angles is on, oops, what happens if the angles happens to be on the axis? What am I doing? What happens if the angles happen to be on the axis? Suppose, for example, 0 degree. Just pick a coordinate on the positive x-axis, which corresponds to 0 degrees. Let's say this is r comma 0, right? Or you can also make it 1 comma 0, okay, which means the distance from origin is 1. Okay, so sine 0 degrees will be y over r. Cosine 0 degrees is x over r. So tangent 0 degrees will be 0 over y over x, which is 0. How about if you have 90 degrees? Now pick a coordinate correspond to 90 degrees. So this is 90 degrees, right? What is the coordinate correspond to that? Pick one. There are a lot of coordinates there. Let's pick 0, 1. So sine 90 degrees will be the y over the radius 1, right? Because the distance here must be 1. Cosine 90 degrees is the x over the radius. Tangent 90 degrees will be y over x, that's undefined. Now, using this technique, we are able to find the value of sine 0 degree, for 90 degrees, for 180 degrees, whose coordinate correspond to that is negative 1, 0, right? Okay. And sine, cosine, tangent of 270 degrees, whose coordinate correspond to that is 0, negative 1. Okay. Now, what I will do now is I will enlarge this table that we have earlier. I will enlarge this table to include 0 degrees and 90 degrees. For 0 degrees, the sine theta is 0, cosine 0 degrees is 1, tangent 0 degrees is 0. While sine 90 degrees is sine 90 degrees is 1, cosine 90 degrees is 0, tangent 90 degrees therefore is undefined. Okay, now you have a new table that you need to memorize. Okay, but the way we get our sine, cosine, tangent of 0 degrees and 90 degrees, actually by picking a coordinate correspond to those angles in rectangular coordinate system. And then from there, see the y over r for the sine, x over r for cosine, and y over x for tangent. Okay. This is the last one you need to memorize. Let me leave it there. I need you to copy that. And I need you to memorize that by Thursday. By Thursday. Memorize by Thursday. Okay. Memorized by Thursday. Now, the rest of this section are on the easy side. First one, part C, basic identities that I need you to memorize. Basic identities that I need you to memorize. Now, basic identities, I make it in groups. And I need you to memorize them in groups. In fact, if possible, in this order. So for example, B1, the basic identity, the first group. That's the group of ratio and reciprocals. Tangent theta is sine theta over cosine theta. Secant theta is the reciprocal of cosine theta. Cosecant theta is the reciprocal of sine. And cotangent theta is the reciprocal of tangent theta. Now, that group tends to be very easy to memorize because they are basically just definition. But you still need to get used to it. Okay, that's the first group. I will not prove the first group. The second group, I will prove a little bit. This is called Pythagorean identity. Consists of 3 identities, and I will number it. If I number it, means you need to memorize in that order. Okay, so B1 is about ratio and reciprocals. Okay, B2 is Pythagorean identities. The first one is sine squared theta plus cosine squared theta equals to 1. The second, tangent squared theta plus 1 is equals to secant squared theta. The third, 1 plus cotangent squared theta is cosecant squared theta. I will prove this later on. I'll prove this later on. Okay, let's write down group 3 first, and then we take a break. After we're done with the break, when we come back, we will work on the proof for Pythagorean identities, and the third one is cofunction identities. Which says the following. Let A and B be complementary angles. In other words, they add up to 90 degrees. Then the first one, sine A equals to cosine B. Tangent A equals to cotangent B. Secant A is equals to cosecant B. If they are complementary angles, then they are related by cofunction. Tangent A is equals to cotangent of the complementary angle. secant A is cosecant of the complementary angles. Now, sometimes other textbook write it in different expression, basically saying that sine 90 degrees minus theta is equals to cosine theta. Notice that when you add these two angles, they add up to 90 degrees, right? Okay, so they are related by cofunctions. Tangent 90 degrees minus theta is cotangent theta. Secant 90 degrees minus theta is cosecant theta. Okay, now let me ask you to copy these formulas here. Copy this down and make sure you memorize that this Thursday. Okay, now we will take a break. When we come back, I will do a little bit more using calculator for this 5.2, and then we go on to 5.3. Okay, let's take a break until 9:27. Okay, let's start. I will prove these identities. B1, I don't prove that anymore. That's just proof. B1, that's just definition. So nothing to prove. How about B2? Let me start with B21. That is sine squared theta plus cosine squared theta equals to 1. That's the proof. Now we will start in the following. Now you see that if we have circle with radius r and angle theta in standard position correspond to coordinate x, y with distance r from the origin. So sine squared theta plus cosine squared theta, that's the left-hand side, that will be equals to y over r squared. I'm sorry, I have a square here. Plus cosine theta is x over r squared. That is equals to y squared over r squared plus x squared over r squared. But because they have common denominator, we can put them together. And by Pythagorean theorem, y squared plus x squared is r squared itself, which is equals to 1. So the left-hand side, which is sine squared theta plus cosine squared theta, okay, using the definition in the rectangular coordinate system, it leads us to have that expression equals to 1. Okay, now this is the first Pythagorean identity that you have to memorize. Do you need to memorize the proof? No, you don't need to memorize the proof. Okay, it would be nice if you can understand the proof. Okay, how we get that sine squared theta plus cosine squared theta equals to 1. But you need to know that formula. Now, how about B22? That is tangent squared theta plus 1 equals to secant squared theta. Now, you can prove that the same way we did earlier. You replace that tangent squared theta by y over x being squared and blah, blah, blah. But So the first way is you write this, oh, this is y over x. That's for tangent, right? Tangent squared theta is y over x plus y over x squared plus 1 equals to y squared over x squared plus 1 equals to y squared over x squared plus x squared over x squared. That is y squared plus x squared over x squared. That is r squared over x squared by Pythagorean theorem. But r over x is secant, right? So this is secant. Maybe I'll write it this way first. This is r over x quantity squared. Now that is equals to secant squared theta. Okay, but most instructors will not like this proof. They don't like it because of preference. It's not because it's wrong. Okay, the preference. You basically do everything from the beginning. The second approach is better. What is the second approach? We try our best when we prove, later on we prove an identity in trigonometry. We will try to use the identities that we already proved in class. So for example, the second approach is we take it from b to 1. That is sine squared theta plus cosine squared theta equals to 1. Now divide these by sine squared theta. Divide that by sine squared theta. Okay, so on the left-hand side, you will get sine squared theta over sine squared theta plus cosine squared theta over cosine over sine squared theta. What am I doing? Divide by cosine, I'm sorry. I want to prove B2 too. I'm sorry. Divide by sine, by cosine squared theta instead. So divide by cosine squared theta instead. Equals to 1 over cosine squared theta. But sine squared theta over cosine squared theta, that's tangent squared theta plus 1 equals to secant squared theta. It's easier proof, shorter. Basically, we divide both sides, each term to be more precise, we divide each terms by cosine squared theta. And likewise for the third formulas, B2, 3, 1 plus cotangent squared theta equals to cosecant squared theta. Proof. You can use the first method. I prefer the second method, which you start from what we already proven earlier, B21. That is sine squared theta plus cosine squared theta equals to 1. But this time we divide each term by sine squared theta. Now, the reason is because when I divide sine squared theta by sine squared theta, that later on becomes 1. Cosine squared theta divided by sine squared theta, that will become cotangent squared theta. 1 divided by sine squared theta, that will be cosecant squared theta. Okay. Now, how about B3, the cofunction identities? I will prove all three at once by looking at this picture. Okay. Let A and B be non-right angles in a right triangle. So if you have a right triangle, let me make it a bit bigger. Okay. And that A and B are not right angles. So they must be the acute angles, right? Okay. Now then, this will be side A, this will be side B, this will be side C. Now take a look at sine A. What is sine A? In that triangle, sine A in that triangle will be A over C. But that happens to be the same to cosine B. Right? A over C in that right triangle is cosine B. What happened? You see that tree? I don't know what happened. Okay, now cosine A will be B over C, but that is the same to sine B. Is it right? Okay, basically, as long as A and B are cofunctions, then cosine of one angle equals to the sine of the complementary angles. Okay. Likewise, if you take a look on the tangent, tangent A is equal to A over B, which is the same to cotangent B. Secant A is C over B. That is the same to cosecant B. Okay, so therefore I already proved what I need. Okay, so consequently, you see, because A and B are not non-right angles in a right triangle, then A and B must be complementary. They add up to 90 degrees. Okay. Then from there we see that sine A equals to cosine B. Tangent A is equals to cotangent B. Secant A is equal to cosecant B. You have to memorize the identities. You don't need to memorize the proof, even though in long run, later on, you need to memorize the proof. Okay, now the last part of this section is on the easy side. How do we use calculator? Okay, let's take a look on number 30. Part A. What is tangent 282 degrees? Part B. What is cotangent negative 81 degrees? Part C. What is secant 202 degrees? And part D. What is sine 97 degrees? Now grab your calculator. We'll do the work here. Grab your calculator. Oh, where's my calculator? We'll use calculator now. Okay, now how do we punch in tangent 282? Now, before you really use your calculator, make sure you are on the right mode. Notice that the angle here are in degree mode, right? So you check your calculator. I happen to use TI-84. If you use TI-30 or TI-36, there should be a way to check the mode. Okay, are you in degree or in radian mode? When I push this, click this mode, you see that the third row here, there's an option radian or degree. I want to work on in degree mode. So I'm already in the correct mode. Okay, now then tangent 282, negative 4.70463. Negative 4.7, what? 0463. Now in my class, if you need to do rounding, round it to 5 decimal places. Okay. Now how about cotangent negative 81 degrees? Now you see that on our calculator, we don't have cotangent, we don't have secant, we don't have cosecant. So how do we compute cotangent? First, you write it as 1 over tangent negative 81 degrees. Now then, when you use your calculator, you punch that in. That's one way to do it. 1 divided by tangent negative. Now when you use negative, when you use the sign negative, don't use subtraction sign, but use this negative sign here. Negative 81. Boom. Negative 0.158338. Negative 0.15838. Likewise, for secant 202 degrees, we don't have secant button on our calculator. So we write it first as 1 over cosine 202 degree. Then you punch that into your calculator. Oops. 1 over cosine 202 degrees. Negative 1.07853. Negative 1.07853. And then the last one, sine 97 degrees. That's easy. We have sine button. Sine 97 degrees is 0.99255. 0.99255. Again, I round it to 5 decimal places. Now, what happens if you don't have the degree sign? If you don't have degree sign, it must be in radian. For example, if you take a look on number 32. Part A, sine negative 0.11. Part D, secant 2 pi over 5. Part C, tangent negative 3 over 13. And part D, cosine 2.4 pi. Then how do we do that? Now change the mode first. How do we know it is in radian terms? If you know that's an angle, but you don't have the degree sign, then it must be in radian measure. Okay, so before I punch that into calculator, I need to change the mode first. The mode, change that to radian. Now, if you use TI-30 or TI-36 or other calculator, you figure out yourself how to change the mode. Okay, how to change the mode from degree to radian, from radian to degree. Now, once we are in radian mode, then sine negative 0.11. Boom. Negative 0.10978. That's negative 0.10978. Is it right? 978? How about secant 2 pi over 5? Secant 2 pi over 5, that's 1 over cosine 2 pi over 5. Using our calculator, that's 1 over cosine 2 pi over 5. Do not use 3.14. Don't use 3.14 in place of pi, because 3.14 is a very much rounded number for pi. Okay, pi is an irrational number, 3.141 blah, 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 a very long number. Okay, you don't want to do rounding. So keep that pi there. You press 2 pi over 5 into your calculator. Okay, 3.23607. 3.23607. Tangent negative 3 over 13. Oh, we have that tangent button. So I will just punch it right away. Tangent negative 3 over 13. Enter. Negative 23495. Negative 0.23495. Negative 0.23495. And cosine 2.4 pi. Cosine 2.4 pi. Done. 0.30902. 0.30902. Okay. Now, suggested homework from this section. I know it's a long section, huh? I spent actually more than 1.5 hours for this one section. 5.2. But because there's a lot of foundation in this section, I would like you to work on number 3 to number 21, number 29 to 33, number 75, 77, 85 to 95. Okay, please do the odd ones. Do as much as you can. Maybe you do every other odd first. Yeah, maybe you do every other odd first, but keep referring back to my notes. Okay, please keep referring back to my notes. Now, this is for this 9.2. I know it's heavy. It's a long section. It's a long sections because I need to lay down the foundation for how to approach trig function as an acute angle. And from there, we get the trig values for special angles, special acute angles. Right? Now, then we superimpose that right triangle into a circle with radius r so that we can get trig functions of angles more than 90 degrees, including quadrantal angles. What if the angles happens to fall on the x or the y-axis? Okay, and using that, we get extended version of that special angles. Instead of 30, 45, 60 degree triangles, we can also now have 0 degrees and 90 degrees. Then we have basic identities. There's one part in this section I will not do now. I will do it later, maybe very likely next week. Instead of Thursday, very likely next week on Tuesday next week. that is verifying identities. Okay, we will wait until we pretty much done with this section. I think until we are done 5.5, 5.6, then right before we do 6.1, basically, right before we do 6.1, then we will do verifying identities, proofing. Okay, I give you the foundation of proofing just now. Okay, but it is more about you memorizing the identities instead of learning to prove yet. And then the last part of this section is using calculator to compute those angles, given angles in degrees and angles in radian, and to anticipate what happens if the trig function is not on your calculator, like cotangent, secant, cosecant. What do you do? Okay, now that's for 5.2. Now 5.3 is actually on the shorter side. Okay, 5.3 is on short side. This is wait until before 6.1. So the first thing we will do here is a trig functions on a unit circle. Now we have had from the previous section saying that if you have a circle, with radius r on a coordinate system, okay, let's say again, this is radius r. This is angle theta, and the coordinate here is x, y. So sine theta is equals to y over r. Cosine theta is x over r. Is that right? That's what we learned before. This is not unit circle because the radius is not 1. Now, suppose I change that r if the radius equals to 1. If the radius equals to 1, then sine theta will be y over 1 or simply y. Cosine theta will be x over 1 or simply x. Okay, so the situation now changed to be as the following. Let me copy this down here, but I changed the radius to be 1. I copy this. Okay, I copy this. But I changed the radius to be 1. Now, what happened then? The coordinate xy there suddenly equals to cosine theta, comma, sine theta. In other words, if you have a unit circle that is a circle centered at origin with radius 1, okay, then the coordinate correspond to angle theta in standard position must be cosine theta, sine theta. So the x component of that coordinate on the unit circle must be cosine, equals to cosine theta, and the y component of that coordinate on unit circle must be corresponding to sine theta. Okay, so What I mean is this, okay, take a look on this coordinate here. This is coordinate 1, 0, right? Now that corresponds to angle 0. So we know right away this is equal to cosine 0 degrees, comma, sine 0 degrees. Therefore, cosine 0 degrees is 1, sine 0 degrees is 0. Boom, that's it. Now, the new thing in this 5.3, is instead of the theta in degrees, you can also talk about that theta in radian. So for example, take a look on the coordinate correspond to this point here. This is coordinate 0, 1, right? Okay. So what is the angle that corresponds to 0, 1? The angle is 90 degrees. Okay, in radian, that's pi over 2, right? Okay, so the x component is cosine pi over 2, or cosine 90 degrees. That's equals to 0. The y component corresponds to the sine of the central angle. That is 1. Now that also gives us the following. Let me insert the, no, I don't want to insert. Let me screenshot the following graph, which we actually, I show you actually last week. Give me a second, the unit circle. Yeah, this one here. If this is a unit circle, can you get the coordinates of these special angles? Can you get the coordinates of these special angles? Now, for example, this is 0 degrees, which corresponds to 0 radian. The coordinate we know to be 1, 0. Right? This is 90 degrees, correspond to pi over 2. Corresponding coordinates is 0, 1, which means cosine pi over 2 is 0, sine pi over 2 is 1. This is 180 degrees. In radian, this is pi. Now, what is cosine pi? Cosine pi will be -1. Sine pi is 0. This is 270 degrees. In radian, that's 3 pi over 2. Corresponding coordinates 0, -1. So please visualize this, okay? Please visualize this. The reason I give you this handout last week for you to print, so that you can print enough and then play with this, okay? Eventually you will memorize it, okay? Now let's do more. For example, what happened to 45 degrees? This is 45 degrees. What is that in radian? That's pi over 4, right? Okay, now what will the coordinate be? Oh, the x component is the same to cosine 45 degree, right? And the y component is equals to sine 45 degree. That's cosine 45 degrees, sine 45 degrees. Because it is in one unit circle, so the x equals to the cosine of that angle, and the y is the sine of that angle. Now, what do you know about cosine 45 degrees? That is radical 2 over 2. Sine 45 degrees also radical 2 over 2. Now, if the angle is 30 degrees, in radian, that's pi over 6. Then what will the coordinate be? Now, that corresponds to cosine 30 degrees for the x component, sine 30 degrees for the y component. Then what do you remember about those values? Sine 30 degrees is 1/2. Cosine 30 degrees is radical 3 over 2. Okay, now 60 degrees correspond to, in radian, that's pi over 3. The x component is cosine 60 degree, which is 1/2. The y component is sine 60 degree, which is radical 3 over 2. Okay, now we will come back to this unit circle in future. On Thursday, we'll come back to that. Okay, we'll come back to that. But let's talk about negative angle. This is actually B4, negative angle identity. Remember B1, 2, 3 are here. This is B1, 2, 3. Okay, B stands for the basic identity. The first group is ratio and reciprocals. The second group, Pythagorean identities. The third group, cofunctions identities. Now, B4, negative angle identities is as the following. Sine negative theta equals to negative sine theta. Cosine negative theta is equals to cosine theta. In other words, you will see that sine is an odd function. If you remember, a function is odd if f negative x equals to negative fx. When we graph that later on, you will see sine function has origin symmetry. Now, cosine, on the other hand, is an even function. It is symmetric with respect to y-axis. A function is even if f negative x equals to fx. So cosine negative theta is cosine theta itself. You will see that consequently, tangent negative theta will be negative tangent theta, but we'll do that later on. The proof. The proof. We will do this using proof by picture. Take a look on a unit circle. Okay, let's say this is angle theta. Let's say this is angle theta. Now we know that the coordinate here must be cosine theta, sine theta, right? Now that's something we learned earlier. Now, what happens if we go negative theta? Well, basically the angle will be the same magnitude, but opposite direction. Now we know the coordinate here will be cosine negative theta, sine negative theta. Is it right? But if you compare the x component, if they go opposite direction, the theta, then you see the x component will be the same x, right? From that picture, you see that the x component must be the same. X component, when you look at the x component, then cosine theta equals to cosine negative theta. Okay, so we already actually proved this second one here. Now, if you look at the y component, however, notice that the y here must be the opposite of the y here, right? If you go opposite direction from positive x-axis, then the x will be the same, but the y will be opposite. In other words, sine negative theta is equals to negative y, which is negative of sine theta. Okay, cosine theta equals to, cosine negative theta is equals to cosine theta, while sine negative theta is negative of sine theta. Now let's use this to answer some questions from our book. For example, number 18a. What is the value of sine negative 3 pi over 2? That is equals to negative of sine 3 pi over 2. Okay, now that is equal to negative what? If we don't use calculator for this. Now, what is sine 3 pi over 2? Sine 3 pi over 2 is the y component with angle equals to 3 pi over 2, right? If the angle is 3 pi over 2, let me borrow the graph from above. This is 3 pi over 2. Okay, that's the angle 3 pi over 2. the corresponding coordinate is this, right? That's 0, -1. Now, what is the y component? The y component of that coordinate will give us sine 3 pi over 2, okay, which is -1. So sine -3 pi over 2 is equal to 1. Okay. How about part B? How about cosine of -225 degrees? Cosine -225 degrees is equals to cosine 225 degrees. Yeah, because cosine is an even function. Now, but cosine of 225 degree is the x component with angle 225 degrees. Okay, the angle 225 degrees is here. Okay, what is the coordinate here? What is the coordinate here? Notice that if this is 225 degrees, if that's 225 degrees, then this is 45 degrees, right? In 5.4, you will see what we call reference angle. Maybe it's easier for us to see that this coordinate here is the opposite of that coordinate. Okay, if this is 45 degrees, instead of doing it there, let me just do a new picture. Let me do a new picture. So 225 degrees is here. You want to know what is the coordinate here, but this is the opposite of 45 degrees, right? The coordinate for 45 degrees radical 2 over 2, comma, radical 2 over 2. So imagine the picture. You need to imagine the picture. Now the opposite of that will be negative radical 2 over 2, negative radical 2 over 2. Now for cosine, you need the x component. The x component is negative radical 2 over 2. For part C, what is tangent of negative pi over 4? Tangent of negative pi over 4 is negative tangent pi over 4. But tangent pi over 4 is 1. That's it. We're done. Okay. Now, suggested homework from here is... Now, we don't do a lot from 5.3. There are things that I don't want you to do too early. I would like to lay down a very good foundation, very strong foundation. So I would like you to do number 1, number 3, 17, 19, and that's all for now. Not a lot. Not a lot to do here. Okay? Now, in the next 10 minutes, we will go over the early part of 5.4. Reference angle and how to use that. So in this section, we will only learn two things, reference angle and how to use reference angle. With the time I have, I can only explain reference angle. So homework 5.3 here. 1, 3, 17, 19. Okay, 1, 3, 17, 19. Okay, reference angle. Definition. The reference angle of angle theta in standard position. So the theta is in standard position. Is denoted theta hat. That's actually the most common notation for reference angle. Our textbook use theta subscript r, but I will use theta hat. Is the acute angle denoted by that is the acute angle formed by the terminal side and x-axis. Okay, now let me explain this. Suppose my angle is in quadrant 1. My angle theta is in quadrant 1. Let's say this is my angle theta. Now the reference angle is from this terminal side to x-axis. Okay. Now that's the reference angle. Now you can see here that if theta is in quadrant 1, then the reference angle is the same. If theta is in quadrant 1, then the reference angle is equals to that angle. Now, if theta is in quadrant 2, this is our, this is our theta. Okay, now then the reference angle will be from the terminal side to x-axis, but it has to be an acute angle. So it must be this one. This is the theta hat. Okay, so you can see that if the theta is in quadrant 2, if the angle is in quadrant 2, then the reference angle is the supplementary angle of that theta. 180 degrees minus theta. Now, if the angle theta is in quadrant 3, if angle theta is in quadrant 3, then the reference angle will be this part here, from the terminal side to the closest x-axis. Okay, this is our theta hat. That's the reference angle. Okay, now in quadrant 3 means theta is between 180 degree to 270 degree. It's more than 180 degrees, right? Okay, so theta hat will be, if theta is in quadrant 3, then theta hat is theta minus 180 degrees instead. So first you need to identify which quadrant that theta is located. Okay, if the theta is in quadrant 4, if theta is in quadrant 4, then the reference angle is this angle here. Notice that theta plus theta hat is 360 degrees. In other words, if theta is in quadrant 4, then the reference angle is 360 degrees minus theta. Okay, now that's what you need to be able to do first before we go on. On Thursday, finding the exact value with the help of this reference angle. Okay, let's do one problem maybe from number 2. Number 2, if theta equals to 290 degrees, which quadrant is that? Remember, this is 90 degrees, 180 degrees, 270 degrees. So 290 degrees is in quadrant 4, right? Okay, what is theta hat? You need to identify first which quadrant is located so that you know which appropriate formula to use. Okay? If it's in quadrant 4, then this is the reference angle, right? That's 360 degrees minus the theta. So theta hat, the reference angle is 70 degrees. That's for part A. Part B, 195 degrees. 195 degrees is here, quadrant 3. It's between 180 to 270. Right, so this is the theta hat. Okay, so theta hat equals to 195 degrees minus 180 degrees. That is 15 degrees. Part C, theta equals to negative 185 degrees. Now this is coterminal to, if you add 360 degrees, this is coterminal to 175 degrees. Then from there you see, oh, it is in quadrant 3. I'm sorry, quadrant 2, right? Now then the reference angle will be this guy here. So theta hat will be 180 degrees minus 175 degrees. That's 5 degrees. What happens if we have theta equals to 400 degrees? Oh, that's more than 360 degrees. Let's see the coterminal. Subtract by 360 degrees. That's 40 degrees. But that's in quadrant 1. So the reference angle must be the same. Okay. Now let me ask you to try on this 5.4a. I would like you to do number 1, number 3, number 5. Okay, that's for today. See you then on Thursday.